Okay, so I'm going to continue the topic of functions with another topic called function notation. Okay? Now, what that means is, for definition, okay, we are going to be evaluating a function at a given number or expression. Okay? So, if I give you an equation now of some sorts or a function, if I say to you, okay, well, how can I evaluate this thing at the number 3? Okay, well, I'm going to show you how you would do something like that. Okay? Now, normally you've probably seen this in another math class, but we're normally pretty accustomed to seeing y equals, I don't know, for example, 2x plus 3. Okay? And if you were to graph this, it would make a line. All right? But now, since we're talking about functions, we're going to get just a little bit more creative. And instead of writing y equals 2x plus 3, you may have seen this before, we're just going to replace y with f of x, looking like that. Okay, and that equals 2x plus 3. So nothing has changed except for the notation, except for how I wrote it out. Y equals 2x plus 3 is exactly the same as saying f of x is equal to 2x plus 3. It's just that we use this to denote that we have a function. So tells that you have a function. Okay? And our goal is going to be, for this little segment, is to figure out, okay, given something like this, if I ask you to find the function at 3, how would you do such a thing? Okay, so let's look at an example of what I'm trying to explain to you here. So for example, let's say that you have the function f of x is equal to 2x plus 3. We'll use that same one. Okay. And I ask you, well, okay, well, if this is a function now, I want you to tell me what f of 5 is. Meaning, I want you to evaluate the function at the number positive 5. Okay, can you make a guess as to what you think you may do? Okay, all you have to do is take the 5 and plug it in where you see an x. Do you see how this 5 is already in place of this x right here? Okay, so you're just going to take 5 and you're going to substitute it in right here. So I should have 2 times that 5 that I'm plugging in plus 3. Okay, and so 2 times 5, of course, is 10. 10 plus 3 is 13. So if you wanted to know the answer now, this function evaluated at 5, well, the answer would be 13. Okay? Now, depending on what your teacher asks you and how detailed you are, remember, this is actually an ordered pair. I can rewrite this as saying that my x was 5, and the entire thing was evaluated at 13. So 513 would be the final answer to this thing. Okay? Just depending on your teacher, of course, whether or not if they want you to have this piece in here, the 5, 13. But ultimately, though, the answer is 13 for what we're looking for. Okay? Let's look at another one. Okay. So let me change up the function a little bit. Suppose I say f of x is equal to x squared plus 2, and I want you to evaluate f of negative 4. Okay. Now, I will tell you right now, just from firsthand experience on dealing with this, anytime that you substitute, anytime that you plug in, evaluate, however you want to phrase it, I always use parentheses. It's such a great idea and it avoids mistakes. So, this negative 4, I'm going to plug that in where I see an x. So here's x, it's right here. So again, I'm going to use parentheses here. Negative 4 squared, and then plus the 2. And then we clean this up. Negative 4 to the second power is negative 4 times negative 4, which is positive 16, plus 2. So the answer is 18. Okay. And if I asked you to write this as an ordered pair, it would be your negative 4, which was our x. And when we plug that in, we got 18. It sort of works almost identical to whole input-output. It's just that we are writing it in a different fashion this time. You haven't really seen this before. Okay. Okay, let's do another couple more. So what if I gave you f of x is equal to 3x squared plus 2x? Okay, now don't freak out. And I want you to find f of 2. Okay. Can you see where I'm going to make a substitution here? How many times actually am I going to make a substitution? Okay. Hopefully you're thinking to yourself 2 because there's 2 x's here, meaning there's one right here and one right here. Okay. So essentially I'm going to have 3. I'm plugging in that 2. Plus 2, again, always use parentheses whenever you plug in, guys. All right. Now, big warning sign here, just a precaution, just in case if you're not really too caught up with your order of operations, and that's going to be like this. To interpret this, it is not 3 times 2 to the second power. No, no, no. It's 2 to the second power times 3 because exponents comes first. So this is actually going to be 2 to the second power is 4. 4 times 3 is 12. Plus 2 times 2, which is 4. And 2 plus 4 is finally 16. Okay. So the answer to this thing as an ordered pair would be written as 2, 16. Okay. All right. Let's do one more of these, for example. All right. If I said to you f of x is equal to negative 3x to the second plus 4, when f is, we want to evaluate this at negative 2. Okay, so again, you're going to take the negative 2 and you're going to plug it in wherever you see an x. And remember to use what? Parentheses. Good. So, negative 3, negative 2 to the second power, plus 4. Okay, remember do your exponents first. So negative 2 to the second power is positive 4. Positive 4 times negative 3 is a negative 12. Plus 4. And finally, when you add that up, you get negative 8. And then as an ordered pair, this would read negative 2, negative 8. Okay. Now in the next little clip here, I'm going to create a couple try problems for you. Just like normally, I want you to pause the video and take a moment and see if you can answer these.